Howdy doody. All right. After a couple days of IQR, measure of variation, time to move on to guess what? Another measure of variation. So we looked at the IQR. We looked at just plain old range, so interquartile range and just range. Those are measures of variation. And the last one we're going to look at in sixth grade is real crazy. This one's called the MAD, not the emotion, MAD, which stands for mean absolute deviation. It's a little crazy, but you'll be able to do this, I think, really well after a bit of practice, and I hope I can explain it in a way that helps you understand. So here we go. Yesterday, or whenever we did the lesson on measures of variation, we started by talking about what that means. Variation just tells us how spread out a set of data is, how varied it is. And so that's what mean absolute deviation does. It tries to tell us how spread out a set of data is. And I think the biggest place to start, or the best place to start, is to talk about what the word deviation means. We know what mean stands for. Mean simply refers to the average, adding all the numbers up, dividing by how many numbers there are. But the word deviation is probably new, and so let's start just by getting a general sense of what the heck this word deviation means. And it just so happens something crazy happened to me today that will help me tell you what deviation means. So I stay locked in my house for the most part, as I'm sure many of you do. I went out to get the mail today, and as I'm walking out to get the mail, this little troll popped up, and I took a picture of him. I'll show you. Um, the troll said, Mr. Carapeza, I will give you 1 million gold coins if I'm going to give you 3 dice. You have to try to roll a 20 with those 3 dice. So my target number to roll for this crazy troll guy was a 20. So he was chuckling. He said, all right, roll the dice. So I rolled the dice, and on my first roll, I rolled a 17. Not a 20, but pretty close. Then I rolled again, and I rolled a 5. Didn't do so hot. I rolled again, and I went over a little bit. I rolled a 23. I rolled another time. He's laughing all the while. And I rolled a 21. I was so close. And he laughed. He said, all right, roll one more time. You'll get it, I'm sure. You're getting closer. So I rolled it, and I rolled a 19. So I didn't roll the 20 that I needed. I didn't get the gold coins. But he said something interesting. He said, you tried to roll a 20, but all of your rolls were deviated from the 20. The 19 was deviated by 1. The 17 was deviated by 3. The 23 was deviated by 3. The 21 was deviated by 1. When he said deviated, he was talking about how far off I was from the 20 target number. So deviated, in math at least, a deviation is an amount that a value differs from another value. So like in this thing that happened to me today, true story by the way, deviated meant all of these, deviation means how far all of these rolls were from my target number of 20. And when we talk about mean absolute deviation, we're going to be talking about how far a number is from something. And I'm going to make sense of that for you right now. Mean absolute deviation is a statistic that measures the distance that data values are from the mean, from the average of the set of data. So what this looks at is it looks at you take a set of data and you find the mean, the average. And then you say, how far is every number that's in the data set How far is each number from the mean, from that target number? That's what mean absolute deviation measures. It measures the how far every number is from the mean. And the best way to make sense of this is just to go through an example. So I like to break things into steps, and that's what I'm going to do for you here. Feel free to pause, rewind, do what you need to do, but we're going to be working with this example data set that I just made up, okay? I made up these numbers here. These are just randomly generated 1, 2, 3, 4, 5, 6, 7, 8 numbers. I've got a 1, 3 2s, 3 4s, and a 5. And we are going to find the MAD, the mean absolute deviation, of this set of data. So step 1, if I want to find out how far each number is from the mean, I have to find the mean first. So our first step is going to be find the mean. And I think most of you can recall, to find the mean, you simply add each number up and then divide. In this case, I'm going to divide by 8 because there are 8 numbers in the set of data. So 1 plus 2 plus 2 plus 2 plus 4 plus 4 plus 4 plus 5, all of that divided by 8. So according to my calculations, the sum of these numbers is 24, which when you divide that by 8 is 3. Cool. So I found the average, I found the mean. The mean of this data set is 3. Now, what we're going to be doing is we're going to be finding the deviations. We're going to be finding how far is each number from the mean. So how far is 1 from 3? How far is 2 from 3? How far is 2 from 3? And so on and so forth. To find the distance, my tip for you is to organize your data. You can use any method you prefer. I like using a table just because it helps me to make sure I've used all the numbers and got everything in order. So that's what I'm going to do right now. The first column I use in the table is the original data value. So originally I had a 1, a 2, a 2, a 2, a 4, a 4, a 4, and a 5. Secondly, I'm going to be comparing each of these to the mean. Well, the average that we just calculated was a 3, and it's a 3 for everything. The mean of the data set is 3. All right, and now deviation, aka distance. We're going to be finding how far is each number from the mean. That's super, super simple. How far is 1 from 3? It's 2 spaces away. How far is 2 from 3? It's 1 space away. 2 from 3, 1 space. How far is 2 from 3? 1 space. How far is 4 from 3? 1 space. 4 from 3, 1 space. How far is 4 from 3? 1 space. And how far is 5 from 3? It's 2 spaces away. You'll notice that I don't have any negative numbers there. It doesn't matter if it's above or below the mean. We're just measuring the distance, and we're not talking about negatives here. So it's always going to be a positive distance. Anyways, now I've got pretty much all I need to do this. I've found the deviations. I found the distance from the mean. And the last step is we are going to find the average distance, aka the mean of the deviations. I wrote that as the step. We are going to find the mean, the average of this column right here. And how do you find a mean? How do you find an average? You add all of the numbers up and divide by the number of pieces of data. So I'm going to add 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 and divide by 8 since there are 8 numbers there. So let's find the mean of the deviations. 2 plus 1 plus 1 plus 1 plus 1 plus 1. Did I have enough? Plus 1 plus 2. I think that's all 8 values, and we're going to divide by 8. 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2 is equal to 10. And when you divide 10 by 8, you get 1.25, 1.25. So we're done. We have found the MAD. This tells us that on average, a number in this set of data is about 1.25 spaces away from the mean. And what that tells me is, since the mean absolute deviation, since the distances from the mean are all pretty small, that means that this data set probably is not very spread out. Everything's pretty close together. Everything's within about 1.25 spaces of the mean. So the mean is a measure of center, and everything's within about 1.25 spaces from the center. That's a pretty close together set of data. Remember, this is a measure of variation. This is not very varied. It's pretty close together. Some of you might be saying, like, what the heck? Why would you even do this? How is this valuable? Well, I've got something for you. What you see on the screen right now is the data for two different pitchers, baseball pitchers. If life were normal right now, if you're a baseball fan, you'd be enjoying watching a game. Go Yankees. I miss baseball, so I'm using a baseball example. Pitcher A, this is 10 different games, and pitcher A in his first game, he let up 4 runs. In the next game, he let up 6 runs. In the next game, he let up 6 runs. In the fourth game, he didn't let up any runs, and so on and so forth. And then you can see the data for a separate pitcher. Pitcher B, we'll call this person. This pitcher let up 6 runs, 4 runs, 4 runs, 5-0, and so on and so forth. Now, let's say it's close to the trade deadline and you're a team that needs to pick up a pitcher. You're going to trade for a pitcher. So you're monitoring these two guys. There are two guys you've got your eye on. Who should you pick up at the trade deadline? Which one's a better target? Well, the first thing you might look at if you're in the data department of the baseball team that's looking to make the trade, you might say, well, what's the average amount of runs that they've allowed over the last 10 games? Well, if you sat there and found the average, you'd find that pitcher A, on average, has let up 3.5 runs per game. And you'd find that pitcher B has also let up 3.5 runs per game. I didn't show the math, but all I did was I added up all of the runs and divided by 10. And both of them happen to have the same exact average. So the mean doesn't actually help me right now. They both have let up the same number of runs. I need something to help me better distinguish these two pitchers. How do I know which one's better than the other? What's another measure that could help me? Well, the mean absolute deviation is going to tell me which person has less variation, which person is more consistent. So I also went ahead and calculated the MAD for each pitcher, and what I found was that pitcher A had a MAD of 2.4, whereas pitcher B had a MAD of 1.4. And since the pitcher B had a lower MAD, that indicates to me that pitcher B has less variation, aka pitcher B is a little more consistent. Yeah, he lets up an average of 3.5 runs per game, but you pretty much know what you're getting. He's not going to be all over the place. He's not going to have games where he lets up 0 and then 8 runs and then whatever. He's much more consistent. You know what you're getting, and that might be something that helps a team decide who they want to get. There's less variation to that guy's data, so maybe he's a more consistent pitcher, and maybe that's what you want for your team. Either way, MAD measures variability, variation in data, and we've gone over how to do it. That's what you're going to be practicing today. You might need to refer back to this, but just go through the steps, right? Step 1, you're finding the mean. Step 2, the distance from each point from the mean. And then lastly, those distances that you found, you're just finding another mean, adding them up and dividing by the number of data points. You can do that. It might take a little bit of practice, but I'm confident you can do it. Have fun as always. Mathematics. Woohoo! See ya.